On today's episode, we're talking about Kairos, which is Greek for weather, or time, or honestly, nobody's quite sure, but it definitely has AI and OS in it, so we're going with it.
We got to chat with Mauro and Dimitris about their CNCF project that lets you turn any Linux distribution into an immutable operating system. Because why support one distro when you can support them all and never have any sleep ever again?
David asked what kind of masochist wakes up one morning and decides to support every Linux. The answer was complicated.
We learned that progression from pets to cattle wasn't and isn't enough. Now we need appliances. Apparently your servers should aspire to be as unchangeable as a smart fridge. You know, the thing that definitely never needs a firmware update at 2 a.m. We went deep into initramfs, AB partitions, and overlay mounts. The good news, your home directory survives reboots. The bad news, so does your shame when you realize you've been SSHing into nodes like it's 2015.
I'm glad David managed to mention NVIDIA, though, which now is the official code word for AI in any cloud-native ecosystem. We also discovered that home labbers are apparently the secret power users here because nothing says I value my free time like running an immutable operating system cluster on a stack of Raspberry Pis.
And the name Kairos. The team originally thought it meant time, but their Greek colleague, who they didn't consult, informed them that it actually means weather. Which works, because when you're sailing Kubernetes, you want good weather with you. I think that metaphor crashed somewhere around the third nautical reference. As did my sanity.
It did.
Yeah.
There you go. Despite the lack of rust, enjoy this immutable episode.
Hello everyone, my name is Mauro. I am originally from Guatemala, but I'm living in Belgium, and I am part of the maintainers of Kairos.
Welcome.
And Dimitris?
Thank you.
I'm Dimitris. I'm also working on the Kairos team, one of the maintainers, located in Greece.
Well, we appreciate you both joining us today to sit down and talk technology. And I'm very excited for this one because we've had a couple of conversations now on Linux operating systems immutability, and I won't put words in Laura's mouth, but I think they're some of our best episodes. We're going to have to continue that and carry the Linux mantle even higher in this episode. For anyone who's listening and is not familiar with what Kairos is, can we give them the elevator pitch?
It's a tricky one.
Oh boy.
Putting the elevator pitch is not so easy because Kairos does many things. But to give you an idea, it's a tool or a framework to convert systems into immutable operating systems. There's a lot more behind that, but maybe that's where we can reduce it the most.
You know, that's a pretty good elevator pitch. I think that kind of works. So basically, it's a tool chain, is what you're saying. It's a tool chain to do things. Or is it more than a tool chain?
The thing is, with operating systems, one thing that I've been noticing since I've been working on this team is that there are many things that we give for granted on the operating system, right? For example, the way it normally upgrades, you change the system where you are into the system that you want to be in the future. And that is normally done through some package manager. But when you move into this concept of immutable systems, you start realizing that the package manager is actually kind of a problem for you because it can leave you in states that are somewhere in between and that you don't understand why it was left in that state. And if you have a fleet of machines, you don't know which of the many of them ended up in one of those states or many of those, right? So it changes completely the perspective because now you start thinking more of life cycle. And that's where all the different other things that I was mentioning of Kairos come.
All right, so
Gotcha.
We'll start on the easy mode, but
He's being nice right now.
Kairos.
Don't be, no need to.
No. It's just there's some low-hanging fruit. Let's just batter that out and then go straight into the fun stuff. That's the stuff that we like to talk about. But it is a CNCF project, right? It is in the Linux immutability space. It's an operating system, potentially, and allows you to build operating systems. And there's a whole bunch of things we can get into in that. But for the end user, right, for those people that are sitting here staring down that CNCF landscape document going, what the fuck, where do I start? What is Kairos to them? When can they use it? What does it do for them? And then we'll get into all the nitty-gritty details.
Yeah. So the way I usually approach it is I'm trying to understand what people need. It is useful to you if you're managing infrastructure. If you have any number of machines that you manage other than your desktop, like your workstation, which is a general purpose system, but if you have infrastructure in the sense that you're deploying workloads on it, no matter what this workload is, Kairos is useful to you. So I've seen people finding Kairos very useful for use cases I've never thought of. So we have people using it to deploy machines in school labs, just because of the immutability and the easy way to reset the system every time, down to customers using it out in the field on drones and such. So if you're deploying workloads on any kind of hardware, Kairos is probably useful to you. No, I want to say, just to clarify, it's not our invention or something. That's the way things actually work. So all the cloud providers have something similar to Kairos to manage their infrastructures. Everybody has come up with some version of it, but we think, we can talk the differences later, I guess. Maybe, correct me if I'm wrong, but I think maybe the most unique feature of Kairos is being distribution agnostic. So it doesn't force you into using one specific distribution, because it allows you to convert any distribution, your favorite, whether vanilla version or your customized one, into an immutable operating system.
So basically, what you're doing is you're not starting from just the ISO. You're starting from, here's my operating system that's currently running, and then building your immutable image from there.
By running, you mean working, kind of running.
Well, so I've gone through and I've set up my operating system to work on one machine. Mm-hmm. And now you want to take it and move basically from the pets version to the cattle version. So Kairos takes the version that you have set up that you've kind of been able to get together however you want it, and it smushes it into a package, or an image in this case, that you can then just plop onto multiple machines, is what you're telling me.
That would be...
Or am I misunderstanding?
Yeah, that would be a concept of snapshotting. So it's a bit misleading. It's not exactly that. So it's more like you got your OS working, and preferably you got it through a Docker file, because that's our preferable way to build. So we start with a container image. Just to be clear, Kairos doesn't need a container runtime. We just use the container images as a way to distribute artifacts. So let's say you build your operating system in a Docker file and you push your image to a registry. You can pass it through the Kairos tooling and get an immutable OS out of it. For example, you could have a single board computer like an NVIDIA board, where usually it comes with an operating system that works with it. You don't want to switch from Ubuntu to OpenSUSE and try to make it work, because NVIDIA told you Ubuntu is working, right? So you got your golden image, the thing that works. So by taking it through Kairos, you get a lot more than what you had originally. So you have a way to upgrade your NVIDIA board without even flashing it. So like over-the-air updates, an immutable OS with AB upgrades, right? Even remote management if you deploy Kubernetes on it. So you have a golden image and you convert it to an immutable OS.
Kairos is a declarative OS, so you don't start from a system that you SSH in and you configure in the way you want, but instead you have Docker files and YAML that both of them help you configure the system either before you even put it in the machine or after, like the difference between a Docker file and a cloud init execution. So to some degree, we could say it's like the recipe or the cookbook or whatever other from the different configuration management systems. And I like that you mentioned this idea of going from the pets to the cattle part. And what we like to say is like, okay, the pets to cattle part was a great progress that we did in the industry, but unfortunately, we never fixed the proper issues that were behind there, that it's drift, right? Like if you have drift and you have configuration management system, you might say, no problem, because it will run every 5 minutes or every 10 minutes and bring back to the correct direction where this system was designed to be. But the problem is that there are many things that your system might have that were not in the recipe. So if someone hacked your system and put rootkit or whatever, your recipe doesn't know, oh, I need to remove the rootkit that someone else put in there, right? So the problem of drift is not really solved. It's just kind of like patched to some degree. While with the approach of the immutable system, what we like to say is that we are now going from cattle to appliances. The idea is you want to have something like an Alexa, like a, smart TV, smart refrigerator, where people don't really have to even think of recipes and these kind of things, but only, okay, I'm going to get the next upgrade and it's either happening or not happening. There's no in-between state between these two. I don't have to manage it to the nitty details. If something goes wrong, it will roll back to the previous version because you always want to have an appliance running, right? So that's how it relates, I would say, to this pets and cattle analogy.
Now, I don't want to simplify anything that's been done, right? But I'm trying to work out how this works. And I know there are other operating systems in this space that do immutability and AB upgrades. But they don't allow you to bring your own operating system, at least not that I've seen, right? That's a pretty unique feature to what Kairos is offering. So I'm assuming because it's container image based, is you're unrolling that OCI image to get a file system. You're sticking read-only flags across everything except /var, and then you're setting up AB partitions on a disk, and that's your job done. I'm sure there's a lot more to it, right? But am I in a right kind of rough idea of what you're doing here?
Yeah, I would say that's pretty good. We start from the container image, then with one line of Kairos, we initialize the system, we call it, which basically takes, makes sure that all the packages that we are going to need are there, plus whatever other packages you included in your system. From that, we produce a kernel and an init ramfs, which is, that's an interesting distinction to mention because generally, when you're installing most general purpose Linuxes out there, the init ramfs is created at the moment that you are installing the machine. But in this case, we already ship it. So that means that you can, in terms of security, you can already start signing these artifacts beforehand and sending them to your fleets. Once you have that, you have what we could call a system OCI image, because it could be bootable at this point if you put it into the right artifact. There we create the ISOs, net booting, raw images, cloud images, whatever you might need. And then you spin up the machine and you have, like you were describing, Kairos takes the responsibility of making it immutable, which means, yes, putting some areas of the system as read-only. Other areas are overlaid because, for example, the active and passive partition, you might want to share, for example, your home directory, right? Like if you upgraded your home directory, you don't want to touch. And normal read-write areas, like you were saying with var, to say something logs, right? You need your systems to write logs, and you don't want to mix the logs between the active and the passive. You want those to stay in the correct system.
Is there any trade-offs being made by building the init ramfs so early in that pipeline rather than knowing the device that you're going to cater to? Because I believe that's responsible for including any drivers that are specific to each individual device. So is that things that need to be known up front? Like, I assume there's some challenges there.
Yeah, you need to think forward, right? The good thing, like Mauro said, is that you can try that on the lab and really try that, because nothing is happening in real time when you deploy or upgrade. The image you're going to test in your lab is going to be the exact same image to the last byte you're going to try in production. So you're more confident that if you missed something right in your init ramfs or whatever, this thing is not going to build again when you deploy. You may have 1,000 nodes, 1,000 machines to upgrade. Every machine will get the exact same image. So there's no way that during the process of installing a package or building a init ramfs or whatever other thing would happen in the standard case, that's going to break. You're more confident because you've done everything beforehand, you've tested it out, so you're just applying the same image everywhere.
Yeah, you really need to plan ahead. That is kind of like a pro and con depending on where you're seeing it, right? Like in terms of if you're expecting a general purpose system, it feels like a con because you want to be able to change it anytime if anything happens. But if you're planning ahead, it's definitely positive because you could also think, okay, but look at this particular system, we actually don't need all this extra firmware because it's very minimal. It only has these 2-3 things. So you can remove all of that and build your init RAMFS with a smaller footprint, for example.
So with that being said then, the fact that you support any operating system also leaves a few questions in my head, right? Because you mentioned that it's a container image. I can stick whatever I want on there. I understand the package manager and all of that. But I mean, I'm assuming there's some Kairos bits that need to get into that image too. I'm assuming you do this without the use of, Red Hat packages, Debian repositories, anything like that. I mean, what does it look like for you to bless that image with the stuff that you need? I'm sure there's a better word. Prime it. Maybe prime the image with the tools that you need. How do you do that?
So originally we based everything in Docker files. So for every different flavor, we had a different Docker file and we applied all the bits and pieces to Kairosify it. We realized it's very complex the way we did it. So we contained the complexity in one tool called Kairos init. So that's the only thing you need. You start from your upstream OS. You call Kairos init, and Kairos init encapsulates all the logic for every flavor we support. So it detects, for example, you're in Fedora, so it knows you have to have these packages in Fedora. It installs them. It's like the provider, the agent, the core. There are, I think, 3 or 4 binaries we put in the image, and the rest is just configuration, systemd services and packages in the supporting packages in the upstream distribution.
The thing is, even if all distributions might ship, I don't know, grub, they might call it differently, right? So we need a single source of truth to know how it's called in the different distributions. And also, I don't know, there are basic packages that we're going to need, for example, for partitioning your system, right? The funny part is that a lot of these packages, these programs, have so much functionality that we don't need in order to convert it to a Kairos image. So one of our colleagues, Ichaka, has been in the task of saying, you know what, I'm going to write our own version in Go to do that. And that has been pretty cool because, I mean, you cannot compare it, right? Like, for example, GDisk does so much, gives you so many options to partition a system, while ours only does that which Kairos needs. But it's really cool because you start realizing that everything is contained within one single binary. What I'm trying to say is when we see it's feasible, we bring it into the Kairos init so that we have the least amount of dependencies, so that we don't have to figure out, wait, what is that package in this distribution, and or be stuck with, wait, did they actually remove that package? Did they rename it here and there? Those kind of problems.
All right. I'm going to ask the hard question now, so brace yourselves. But, now that you're at the point, right, Kairosify or Kairos init, some sort of binary that then has configuration that says, this is how I make this work for Fedora, this is how I make this work for Debian, this is how I make this work for Linux, right? Whatever you want to support at that point. And then you get into, okay, well, how do we slimify this image down to be smaller? At some point, the question in my head would be, well, why not just control it vertically, right? Control the OS and just say you have to use Kairos OS, which is our predetermined, pre-built, super slim operating system, or you have to use Fedora. What was the idea in your head? What was the mentality? Why did you decide we should support whatever our customers want to bring? Like, what was the driving factor there?
There are different reasons, to be honest. The thing is, when you see enterprise, you will see that they have different needs. Sometimes multiple needs within the same enterprise. For example, some people are already paying for licenses and their security department requires them, they continue paying for their, for example, Red Hat licenses. So in that case, if you needed a solution, you find this other immutable system very cool, and you would like to bring it and give it to your developers, but all of a sudden you cannot use it. In the case of Kairos, no problem. Let's just transform it into an immutable version of that original system that you're already paying licenses for. Another case is what Dimitris was mentioning with NVIDIA boards. NVIDIA basically tells you this is the OS that you are supposed to use. And if you do something different, you're on your own, is your problem, right? So ideally, you just check what's inside that OS. Most of them are starting with, for example, Ubuntu 22.04. You check which firmware they install, and then you can put that into your NVIDIA boards. Each user has different needs. It might be size. It might be your team already has certain know-how for one of the distributions, so on and so forth.
All right.
And I can think of at least one more important reason, if I can add to that. So the way it's built right now, don't only think about different distributions, think about the Kairos team not dealing with the base OS. We could as well just have Ubuntu, but let's say you build a company, you invest a lot in Kairos, and all of a sudden the Kairos maintainers team is too small for you because CVEs come out too quickly, and we are very busy building features and all, right? And you keep pinging us and say, hey, guys, you're not pushing the images fast enough for me, right? What do? You don't need the Kairos team anymore. So we have, for example, a reusable pipeline, a GitHub action, where you just specify the options in your YAML. You can put it in any free GitHub repository, right? And get your own image nightly. Every night you can build an image. You don't even have to wait for us. By separating how you build the base image, you are completely free from that. You don't need the Kairos team to stay up to date or make modifications or anything. You don't need us, for example, to create a package, a new package that is not there. You can build it yourself, apply that before you even Kairosify the image, and when you're satisfied, you Kairosify it. So when you create a Kairos, even little, I shouldn't promise so much, but there's not a lot of assumptions Kairos makes, right? For example, it expects systemd or OpenRC to be there. I don't know, maybe it expects certain disk size, things like that, requirements, but there is not a lot. So if you started from a popular distribution, it's very likely that you can make a Kairos artifact out of it.
Thank you for that. That's great context. And as you were talking, I was thinking, you both look like nice people. And I'm curious, you're going like, where the hell is he going with this? And Laura's already laughing at me.
Jeez, David, all right.
But I imagine that it takes them pretty terrible people with too much spare time and an alcohol problem to wake up one morning and go, I'm going to build a toolkit to make any Linux distribution immutable, right? I mean, that's a certain kind of masochist. So.
I mean, hold on a second. There are more than one set of tool chains that does this.
Probably all built by the same self-loving masochists.
But what are you implying?
Curious, what was the motivation? What made you wake up one day and think, this is the problem that I want to solve? I'm assuming it's to do with your roles. Maybe it's Spectral, maybe it was a previous client, customer, whatever. Like, there must have been an origin story. What made you want to solve this problem?
That's a good one. I don't think we are the right people to answer it because Ettore, the main creator of Kairos, but I can try to give a bit of context there maybe and save his reputation as a masochist or not. We'll see. I think it comes from K3S at some point had a OS called K3 OS. I think at that point they moved to SUSE or something like that. And of course, SUSE already has an OS. So I think SUSE decided not to go with the K3OS version, but instead they have something that is called MicroOS, I believe. Sorry if this is not very... This is the legend that I know. Yeah, Ettore thought it's actually a great idea and it would be great to have it on different systems, not just on the SUSE version of it, let's say. And that's how he started seeing if it could be implemented in different operating systems. I think there's also something related about another project from SUSE called Elemental Toolkit. And the two things together allowed him already to do a lot of this. So it's not like he started from scratch trying to solve the problem. There was a big portion already working.
So I guess my question is, when I take a look at this, full disclosure, obviously I work somewhere that has a similar thing that got donated recently to the CNCF. So there's the Bootsy project that's also in the CNCF. And there's a number of other groups looking into the immutable operating system. We have the systemd, one that is trying to do the immutable operating system or the artifact-based systems. System D itself is actually working on a tool chain that does some kind of update in place layering of an operating system.
Got
So
it.
you have
Yeah,
your
system
operating system core and things
extensions.
yeah, something like that. I guess I'm just curious, and there's like OS tree, which was the precursor to boot C, things like that. I'm kind of curious how everybody kind of ended up at the same spot, which is interesting, but also how are various pieces different across all of these different tool chains and different systems? I don't know a ton about it. So as much as I might know a little bit, I know only a little bit. I know enough to be dangerous. How about that? But I'm curious, how do you see yourself in the ecosystem? How is it different than some of these other things that are out there? Knowing that there's also the ecosystem outside of the CNCF that is exploring the same thing. And why do you think that now is when people are starting to look at this? What's caused this interest all of a sudden?
I think for that we do need to touch a little bit on the story, because I think this has started a while ago already. I don't think this is very new, to be honest. If I understand correctly, some of the first to try this out were Google with Google COS or COS. I don't know how they
ContainerOS, yeah.
pronounce it. And the same thing with CoreOS, I believe. I don't know if they happened around the same time or not. I think CoreOS was aiming already at the container workloads and started
They
seeing the need for immutability in that sense. And I think, on the other hand, Google COS was thinking on their laptops, what are they called? I forget. The Chromebooks, correct. So how to provide over-the-air updates like you do on Android, but on a Linux system, right? So I think the problem has existed for a while, and we've seen that the immutable system is actually a good solution for it, because if you see how people use Android, iOS, and Chromebooks, it does work pretty well, right? Like, it depends on what you want to do with your machine, of course. You might want to have more or less control of it. I'm not suggesting that every system should be immutable, but it's a very good solution for certain scenarios. And then in terms of the different solutions, how to approach this, good question. I don't know how different all of these systems are, to be honest. I focused mostly on the Kairos part. And what I can tell you is that we have based pretty much everything that Kairos is, the way Kairos is solving it is based pretty much on the vision from System D. There's a blog post out there, I don't remember the title right now, but where Leonard Pottering describes how the ideal booting of a system should happen. And he's basically describing this unified system images approach. Kairos, I would say, basically just took that as a recipe and started tackling, and that's how we ended up with the system we have today.
But there is collaboration, right? So there is a special interest group. So we've been talking with the other projects, the open source ones at least. So we're exchanging information. It's not that you have to be different. I mean, we don't necessarily need to have a different project, right? The moment they all start looking the same, we could as well just mix them. But they diverge so much because every project is taking different decisions and architectural choices because of reasons like what kind of use cases they target. That I think, I mean, you actually need to try them out to understand more on how different they are. On paper, if you just list down the features, they look very similar, but the user experience when you use them is very different, I think.
That's fair. Yeah, I guess I'm just curious because there are so many now choices, and almost getting back to David's question about why would you do this to yourself? It's just interesting that so many people went down this path around the same time and started playing with it and I kind of wonder if it's a little bit also driven by the ecosystem of, hey, we've got these VMs. We've now done this whole thing with Kubernetes where we've moved on, like you were mentioning earlier, that kind of looking at the difference of here was the first era of pets to cattle, and it was like all the Kubernetes clusters. Now we're looking at VMs and going, what can we do with them? But also we're looking at bare metal. And so it's almost like we're kind of at that inflection point where we've done this layer. Now it's time to play with this layer. And suddenly everybody's coming out of the woodwork. It seems like that. And I'm curious if my impression is shared or if that's off base.
No, I think you're absolutely right. I think we're starting also to see a lot more of these hybrid clouds, right? And to some degree, you might want to have the same experience on both. And how can you guarantee that? It's not so easy if you don't have control from the operating system level and up, right? So I think there's some of that for sure.
We also have data sovereignty too. So there's a lot of different groups interested in moving
American
off
companies.
of
Actually
your
sit and talk
big
to
clouds.
the
and-
Europeans. So I point that out.
I mean, public clouds in general, I think, though. It's not just American companies, but I mean, understandably so. Being the only US-based person on this call, I completely understand why.
Yeah.
Just saying. But at the same time, I'm also just thinking that as you start to move down that stack, you know, I've got history back at Rackspace, so I understand that whole idea of hosting from the bare metal all the way up. And suddenly everybody's having to explore that again, but they want the fun tooling that they have somewhere else, and so now they're exploring how can we build it. So I don't know, maybe it's just me, maybe I'm the only one who's kind of watching these trends and kind of going back all the way back to when we all were hosting our own stuff on bare metal.
I don't
just
think this is
running with it, and now it seems like we're trying to do the same thing. Just
I don't think this is
scale.
coincidence. I think you're right. I mean, there is a layered approach here, and I think everyone's in agreement to a certain degree. Like, this is it's not a coincidence that these things are happening right now. Is that the cloud migration forced us all to take a different approach, right? You know, pets go away, cattle comes in. But then why are we doing upgrades in place, right? Why did we have Puppet and SaltStack and Ansible? And why did we do continuous reconciliation within a machine, which over time gets messy and noisy? And if you've been hacked, you're still hacked after the next upgrade. And then the cloud VMs disappear. So then we said, okay, we need to become ephemeral. And then the next natural step is, okay, we have to actually just be immutable. Like, let's just eradicate an entire class of security problems. And not even just security, right? Misconfiguration, people SSHing in and, you know, typing the bad words and stuff like that. Like, all of these things disappear and our lives get easier to get more sleep. Yeah. And then it builds us for resilience and redundancy, because if we have an immutable system, we can't use that as a temporary cache for temporary files and temporary credentials. And we force ourselves into better practices. And I feel now we're systematically getting down to the operating system layer, and then the next step towards some sort of unification of all of this into an ideal delivery pipeline for not just applications, but kernels too. And I'm very excited for that future. And I'm thrilled to see so many companies out there trying to solve this problem, because I think it's going to get all of this. And I'm trying not to say AI, right? But I'm going to blame Mauro first, because he mentioned NVIDIA earlier, which is just like the alias for AI.
Is this the new Go or Rust in this conversation?
But no, but with demands for...
You suddenly now will just mention AI every single time we have a podcast?
But with demands for AI and compute and hybrid, these good practices have to come along.
Since you mentioned it, I can throw some more AI keywords if you want, if it helps the podcast. So it kind of reminds me of the AI, because I'm a backend developer, I would say. So I didn't touch JavaScript for no reason, but nowadays I write, no, not me really, but I write lots of JavaScript. So AI opened some doors for me. And I think that kind of was the case for managing OSs. If you remember, I don't know how many years, like 5 years back, everybody was trying to find an easy way to deploy Kubernetes, for example. Initially, everybody was trying to convince people that Kubernetes is not hard to use. Then when we got past that point, everybody was trying to convince people that Kubernetes is not hard to even deploy, not just use, right? So the moment people realized they can actually deploy their own Kubernetes, they had a new problem. Okay, what on earth? Where do I deploy it on, right? And I have a new problem. I have the OS problem. So every time a new door opens, you can do something new. You discover new problems you never had before. So maybe I'm guessing it could be a reason of the hype with OSs now and more projects being created, because people do have this problem now. They didn't have it before.
Yeah. That's a good point. I would also mention that I think all of this is probably driven by enterprise, but at the same time, when I see our community, the ones that are coming often, they are home labbers. And we're now in a situation where it's a lot easier as a home labber to have a stack of machines, right? Like whether it is Raspberry Pis or used mini computers or whatever you can get your hands on. And you're doing your home lab stuff in your free time. You don't want to waste 5 minutes, right? Like those 5 minutes are holy. And if you have a good way to administrate your fleet, I've seen people be very happy in their home labs using Kairos.
Yeah, that makes sense. I've been watching this is Bootsy related, but the Bazite community take off with all of the various people trying out Linux for the first time, but they're doing it for gaming purposes. They're trying it on their Steam decks. They're doing this, that, the other. And I guess I'm seeing the same thing of it's the home labbers coming in and exploring it. It's the people who are exploring this for hobby purposes more often than not. And they're enjoying the sudden freedom of having it and also not really having to think as much about the security side of it because it is an immutable system, or the core of it is they can always have a safe rollback, which is also what CoreOS did way back when. I may or may not have run my own update server because I couldn't actually allow the updates coming in the way they were supposed to. But I mean, that was kind of the idea is here, no, you don't have to think about this part any longer. It's just going to roll in. And now we're seeing it again in various functions in various ways. It's interesting. It's an interesting idea.
Yeah, I think it's cool. I wouldn't recommend it for your... I don't know. I've tried it on the desktop and I keep removing it and just bring it back a traditional Linux. But on the servers, it's really nice.
Kind of depends on your personality, I guess. How much you want to be able to play with your Linux distribution.
All right. Well, I've got some bad news, Laura, but we are over 40 minutes again. So the streak continues. But it has been a fantastic conversation. I think we should just finish with one or two simple questions and then we'll let you get back to your day. Let's assume people listen to this. There's a lot of buzz, a lot of interest in immutability and Linux and open source, right? People want to contribute. How can they get involved in the Kairos project? Where do you hang out? What's coming next for Kairos? Let's shed a bit more light and get people excited and hopefully involved as well.
Mm-hmm.
I mean, we're in at least two chats. One is the Cloud Native Slack. The whole team is there. We also keep popping up in Matrix. So at least me, I'm in Matrix. We do our planning meetings in public as well on Mondays. We used to do that in European afternoon. Then we didn't have so many people joining from US time zones. So we switched back to a friendlier time. But it is open and public. So anybody can jump in the call. And we try to accommodate for them so we don't discuss all the details of every ticket. We just give some time to people to express their needs and all so they can jump out. So it's a very friendly meeting. And yeah, we're trying to be in as many places as possible. So communication, I don't think is a problem. Maybe contribution is a bit because it's such a deep stack. So the Kairos project is dealing from down to the kernel up to, I don't know, maybe even web interfaces for the factory. Depending on what you're feeling comfortable with, it could as well be just documentation fixing, which is a very useful thing. It's so massive, the documentation, that obviously there are a lot of things that are out of date. So we have people fixing it all the time. That's how documentation keeps getting updated. So yeah, there is something for everybody. That's what I want to say. And we welcome everybody to fix the things themselves. We try to review PRs as fast as possible, not let them be rot. Let them rot.
Yeah.
And just to throw some links there, kairos.io, that's the website where you will find the links to GitHub repositories and to the channels that Dimitris was mentioning.
And just to spell that for folks, because
yes.
I know me and things, that's a Kairos. And yes, there's an AI and OS in it as well.
Good point.
Good one. I see what you did there.
Where does the name come from? What does the name mean?
All right.
That's a tricky one. I think we needed it to be Greek because, to be with the theme of Kubernetes, but we didn't ask our Greek colleague to come up with it.
Absolutely brilliant. There we go.
Everyone thought it meant more like kind of time, but then Dimitris, maybe you can explain what it is.
Yeah, I mean, it does mean time. But when you say Kairos, that's the Greek word. The Greek person usually they think of the weather. It's the same word. It means both time. So we kind of fixed it because I said, okay, Kairos is fine as a weather because when you're sailing, Kubernetes sailing, the thing you want to be with you is the weather. You need good weather. So we fixed it like that. So it means weather.
That works. I like this. This is fine. You have to also weather all of the downtime that you would have had before, and now you don't have as much. How about that?
Indeed.
Perfect.
That's a good one.
I don't know.
Fixing it even more. Thank you.
There you go.
All right. Well, thank you both for your time, for joining us today, for sharing all of your flavor, history, and context about the project. I hope people, are very excited by it. I hope they get involved. Jump into the Slack channel, jump into GitHub, have lots of fun.
Thanks for joining us.
If you want to keep up with us, consider subscribing to the podcast on your favorite podcasting app, or even go to cloudnativecampus.fm.
And if you want us to talk with someone specific or cover a specific topic, reach out to us on any social media platform.
Until next time, when exploring the cloud native landscape, on 3,
On 3.
1, 2, 3. Don't forget your
Don't
compass.
forget your compass.